Hello and welcome to this video tutorial for AETATS Plus. My name is Bartek Skorupa and today I am going to tell you a few words about rotations in 3D space. This is a composition and a layer that is a 3D layer, and if we hit W, we can rotate this layer to whatever angle we want. We can constrain the rotation to a certain axis just by hovering the mouse over this axis, and right now we are rotating only on the x-axis, y-axis, z-axis. We can change those arrows to represent the world coordinates. Right now they are representing the layer's coordinates, those are the world coordinates, and those are the view coordinates, which are at the moment exactly the same as the world coordinates, but if we change this from active camera to custom view, those are the view coordinates, those are the world coordinates, and those are the layer's coordinates. Setting the rotation of the layer to whatever angle we want is very intuitive and very easy. Let's now take a look at the properties that control the rotations. Let's hit R and we can see that we have two sets of properties, the orientation and the rotation. And right now when I manipulate this layer here in the compositions panel, I change only the rotation and the orientation remains untouched, because this guy is set to rotation. This is not the default setting, the default is the orientation, and right now if I set it to orientation, when I manipulate this layer here in the compositions panel, only the orientation changes and the rotations remain untouched. So now the question, why do we have two sets of parameters? Isn't it possible to set the rotation of the object just by using the orientation or just by using the rotation? At first it may seem that they behave exactly the same. Let's reset the rotation parameters and set the orientation to some values. Like this value represents the x-axis, so let's set it to 15, y, let's set it to 20, and let's set the z-axis to, let's say, 50. Let's move this layer somewhere here and let's duplicate it. And for this layer, we will reset the orientation and set the rotation values to exactly those values. So 15 for X, 20 for Y, and 50 for Z. And as you can see, this object, this layer is oriented, rotated, exactly the same as this one. So do we need two parameters for controlling the rotation or orientation, however we call it? So let's for the moment imagine that we don't have the rotation parameters but only the orientation. And let's imagine that we want to create the animation. Let's set a keyframe for the orientation, go 20 frames forwards, and let's now animate the Z orientation. So we want the layer to rotate from this angle to, let's say, this angle. So in between keyframes we would expect this layer to rotate like this, clockwise. But let's see what happens if we play this animation back. As you can see, it rotates backwards. So let's, instead of using the orientation, use the rotation and see what happens. I will do it on this layer. So here I have the rotation of this object, of this layer, set exactly to the same values as the orientation of this one. So let's set the keyframes for those properties. Go to frame 20 and set the Z rotation to 300 degrees. And let's play this animation back. So as you can see, when we animate the rotation, the layer behaves exactly as expected. So we may say, okay, we don't need orientation at all. But before we say so, let's take a look at another scenario. I will animate the rotation properties of this layer. Let's set the Y rotation to 90 degrees, Z rotation to 60, and we have the keyframes for all of the rotations, couple of frames forwards, and let's rotate this layer along its local x-axis like this. Now let's recreate this animation on this layer using the orientation, and let's play it back. So I rotated those layers along their local x-axis, and here we have the orientation animated, here the rotation. And as you can see, the orientation reflects the movement that I wanted, and this layer went completely crazy. So at first it seemed that rotation and orientation are exactly the same. And if we simply want to set the rotation or orientation of any layer to whatever angle we want, there is absolutely no difference. But when we are animating, we see that in some cases orientation works better, and in other cases we would rather animate the rotation. Everything seems very intuitive when the layers rotation and orientation are reset. We change the X rotation, and as you can see, the layer rotates as it should. Let's now change the Y rotation and Z rotation. No surprises whatsoever. The arrows right now represent the local layer's coordinates. So it seems that those values represent the local coordinates of the layer. But do they? Let's now try to change the Y rotation of this layer. What do we expect to happen? It should simply use the Y-axis, the local Y-axis. But just see what happens. Let's change the X rotation. Intuitively, we don't expect this behavior. So maybe those values represent the world coordinates. Let's change the arrows to world coordinates, change the X rotation. Well, it seems that we found the answer. Let's change the Y rotation. Whoops. Z rotation. So now, what do those values really represent? Where are those axes that the layer is rotated when we change those values here? And everything becomes even more interesting when we try to use those gizmos to rotate the layer. Watch the values of the rotations when I use those gizmos. When I use the X-axis, only the X rotation changes. When I use the Y-axis, all of the values change. Z-axis as well. Okay, let's change this to local coordinates. X-axis, all of the values change. Y-axis, all of the values change. Z-axis, only the Z value changes. Let's now change this one to orientation and see what happens. X orientation, Y orientation. Everything went completely crazy. And now if we want to change any parameter here, it is very difficult to determine what axis will be used to change the orientation or rotation of this layer. So how can we figure this out? Let's start with some theoretical background. When setting or animating the rotations in 3D space, there are two mathematical models that are most commonly used. One is called Euler Rotations and the second one Quaternions. Euler is more intuitive because it bases on the axis. We simply specify what is the angle of every of the three axes, and we know what is the rotation or orientation of the object. Quaternions are a little bit more complicated. I will not even try to explain the mathematical basis of this model. This model works in 4 dimensions. We have 4 figures that describe the orientation of the object, and they are by no means understandable for a normal human being. To make things a little bit less complicated, we may say that we have some vector that describes the point on the surrounding sphere. So this tells us where this object is pointing. And we also have the role of the object. And those data can be described as the set of 4 numbers. And for us, the most important feature of this model is that when we have one orientation and set a keyframe, and then further in time we have some other orientation, the shortest route between one and the other will be found. So this way we don't face the problem that we saw when animating the rotation of the object, where the layer went completely crazy in between keyframes. We may say something like that. Quaternions describe the state of the object. Quaternions describe the orientation of the object. And Euler says how we should rotate the object on every of the 3 axes to get to this state. This describes the result, and this how to get to this result. the angle of 0 degrees gives us the same result as the angle of 360 degrees, and the same result as the angle of 720 degrees. But when we are animating the angles, and we want to animate between 0 degrees and 720 degrees, our object will make two evolutions. But 0 degrees and 720 degrees, described in quaternions, gives exactly the same values. So the object will not rotate at all. In After Effects, orientation uses the quaternion model, and this layer has the orientation animated. So we have the first orientation and the last orientation, and this layer doesn't care about the angles. It simply finds the shortest route between this state and this state. That's why it visually rotates smoothly along the local x-axis of the layer. This layer goes from the same state to the same state, but it uses the rotations. Rotations in After Effects use the Euler model, so everything bases on the angles. And in order to get from this state to this state, you see that all of the angles need to be changed, and they are interpolated individually, so that's why we can achieve this weird result. And in this composition, we have such animation. We rotate this layer along the z-axis between 60 degrees and 280 degrees. This layer goes all the way between 60 degrees and 280 degrees. And this finds the shortest route between one state and the other state. And the shortest route in this case is not as the desired route. So orientation uses quaternion mathematical model. But you will immediately notice that we are not given the weird 4 values for quaternions, but here we see the angles exactly the same as here in rotations. It's just so that we can understand this. All of the operations are made on quaternions, and here we are given the Euler representation of this orientation. Okay, so let's now focus on the Euler rotation, the model that is used here, and see why we have the problems that we have. First, let's ask one question. Is it enough to say that the x rotation of some object is 30 degrees, y rotation 20, and z rotation 30? No, it's not. Exactly those values may represent 6 different orientations. Let me show you what I mean. Here we have 6 exactly the same objects in 3D space. Their rotations are set to 0 degrees on each axis. Let me now rotate them all 45 degrees on each axis. But I will use the different rotation order. So this object I will first rotate 45 degrees along x-axis, then along y-axis, and then 45 degrees along z-axis. This 45 degrees along x, then z, and then y. And this one, y first, then x, and then z. Y, z, and x, z, x, y, z, y, x. The same angles along the same axis, but the orientations are completely different. The only thing I changed was the order of the rotations. In Euler rotation model, the axes are parented to one another. In After Effects, x rotation is on the top of the hierarchy. Y is parented to x, z is parented to y. So when we rotate along x-axis, the other two axes follow. When we rotate along y, x-axis stays untouched, and the z follows the y. Z-axis doesn't influence the other two. This Euler rotation order is called ZYX. The problems begin when we play too much with the axis that is in the middle of the hierarchy, in our case the y-axis. When we set the y rotation to 90 degrees, you see that x-axis and the z-axis align. This is called gimbal lock. We should always avoid this. But this would mean that we cannot set the y rotation to 90 degrees. Well, that's not exactly true. We can avoid gimbal lock by changing the rotation order. Everything depends on the kind of the animation that we are creating. In some cases, this rotation order works perfectly. In others, we would want to change it. In most of the 3D applications, I can change the rotation order very easily. Here I am using Blender. This object has the rotations of 45 degrees along each axis. And right now it uses the X, Y, Z Euler rotation order, which means that Z is at the top of the hierarchy, Y is parented to Z, and X parented to Y. And here I can simply choose the order that I want to use. As you can see, I changed the order, the angles didn't change, but the orientation is completely different. If I want, I can also use the quaternion model. And here you can see those four weird figures that I was talking about. But we are in After Effects and we don't have the option to change the rotation order. The only thing we can do is to add additional objects like null objects, make them 3D, and simply create our own parenting structure. Let me show you some examples. A camera would be a good one. When you add the camera to your composition, by default you don't animate the rotations or orientations. You set the position of the camera and the point of interest. And the camera will always be focused on the point of interest, but we can change it. We can choose Layer, Transform, Auto Orient and set it to Off, and the point of interest disappeared, and now we can rotate our camera. Z, Y, X rotation order used in rotations in After Effects is one of the worst choices for the camera animation. Y rotation would be most probably very often used. Let's say that you want to look to the side and you can very easily reach the gimbal lock. The best way to set the proper rotation order for camera is to imagine how the camera works in the real world. Let's imagine the camera on a tripod or a dolly. You can tilt, you can pan, and you can bank, which is very rare. Let's say that we tilt down a little bit. Y rotation is parented to X rotation, so if we change the Y rotation, the camera behaves like this, and this is not the natural movement of the camera. We would rather expect the camera to move like this. So Y should be the parent of X. And because Z, or banking the camera, is very rarely used, we should make it the child of everything. Here I have created such structure. I have the null object that I call pan, and I will animate only the Y rotation of this object. This one I call tilt, and I will rotate this only on the X axis, and it's parented to this one. And I have parented the camera to this null object, and I will animate only the Z rotation of the camera. For this layer, I don't want to animate the orientation or X or Z rotation, so I will log them by simple expressions. Alt-click the stopwatch for the orientation and let's simply open square bracket, 0, 0, 0, close bracket and enter on a numpad. For X rotation, let's simply type in 0 and the same for Z. And Shift-Alt-click the property to hide it. And for this layer, I have locked the orientation and Y and Z rotations. And everything but the Z rotation is locked for the camera. So now I can select all of those layers, I have them visible, and now I can easily animate everything. I can tilt the camera, let's say that I will tilt up. I can pan, and if I want to, I can bank. This parenting structure gives the least chance of hitting the gimbal lock. And the last thing that I wanted to tell you about is the relation between orientation and rotation, which may be very helpful. We know what problems we are facing when animating the orientation, and we learned about the gimbal lock problem that we have when animating the rotations. I have set the orientation of this layer to those values, 20, 90, 60. Let's say that I want this layer to rotate twice along the local x-axis. If I use the orientation only, I can set a keyframe, and here on frame 100 I will change the local x orientation. I can rotate this some more, and more. Okay, I made 2 evolutions, but the animation will simply look like this. We know the problems that we will have when animating the rotations only. X-axis is at the top of the hierarchy, So if I set the rotations of this layer to those values, it will be impossible to rotate smoothly along the local x-axis. But we can make use of the relations between orientation and rotations. Orientation is the parent of rotations. So I can set the orientation to something like this. I don't need the keyframe, and right now, when I animate the rotation, everything will go smoothly. Let's go to frame 100 and simply rotate it, let's say twice. So I will simply type in -2 times 0, and I have the smooth animation along the x-axis. So that's all from me in this episode. I hope you find it useful. Thank you very much, take care, and see you next time.